Welcome back to another video, and today, well, we're going to be able to place our planets inside of this puzzle over here. And while we don't have these planets all placed down, we're not really going to be able to interact with the puzzle, but once we do, the puzzle is going to start to move. So really quickly, let me show you what I've done with our round puzzle. So I changed the meshes to these rings. All three of these are exactly the same mesh. The only difference is that some of them are lifted up in the Z-axis and also the higher ones are scaled down. And it is very important in this case to make sure that all three of the axes are the same size so that the planet that we're going to attach to this is perfectly round. Now what we're going to do first is we're going to create all the necessary things that we need for our project with the interface and all that stuff. And the first thing what I'm going to do, since we are inside of our BP round, I'm going to go ahead, select any of the components, and we're going to add a arrow component. Now technically you can add any component. I'm usually using arrow components for this, and these are going to be like the placeholders. So first we have the ring 1. So this guy is the top ring. So I'm going to move this up and bring this to somewhere roughly over here and make sure that it is roughly somewhere in the middle like this. Like so. And then just so that I can see where exactly the planet is going to be in, then I'm going to select the ring once more, and I'm going to add a static mesh component, and I'm going to make sure that I copy the location from the arrow and I pass this to the mesh like this. Then I'm going to give this our mesh, so we have our earth mesh like this. I'm going to hold left control to select both of the components so that I can adjust the arrow so that it would be something like this in the end, like this. Okay, then I'm going to select both of these. I'm going to go ahead and duplicate these, and I'm going to drag both of these to another ring, and I'm going to make sure to adjust these to this ring. I'm going to bring this down a bit, and I'm going to change actually the scaling of this to 1, 1, 1. Because I can see that it's a bit too big. Okay, so let's move this back down real quick, like this, like this, and then we're gonna do this once more for this guy as well. Now for some reason it is flattened, which is very interesting. Oh, because the scaling of the ring is incorrect, so we want to make sure all three axes are the same, and boom, now we have the correct size. Here we go. Okay, something like this roughly should do the trick. So what I'm going to do next is I'm going to get rid of these static meshes. I'm going to delete these guys. I'm going to leave the arrows because those are going to be the locations where the meshes will be spawned in. So let me rename these two. So let's call this Jupiter place. Then we're going to have the Earth place, and then we're going to have the Mars place, like this. So I have 3 planets. Okay, so far so good. Now let's go ahead and let's modify our puzzle data. So let's go to our S puzzle data. Now let's add a new variable, and let's call this item needed. And this is going to be our data table row handle, so it can call an item from our database. And then we're going to add another one, and we're going to call this item placed. And this is going to be a boolean, and it's going to tell us whether we have placed this item before or not. The next thing that we need to modify is our puzzle interface. We're going to need to add a couple of more functions. So right now all we have is this open door, and we're going to need 2 more. So first, add function. Let's call this give item to puzzle. And this guy is going to need 2 inputs. So first, we're going to need the item, which again is our data table row handle. And then also, just so that it's easier a bit with the code, I'm also going to pass along the index, so we know in which slot we need to place this in. So that's going to be an integer. And then we're going to add another function, and we're going to call this return puzzle data, which is going to have a single output, which is going to be data. And this is going to be our S puzzle data structure type. S puzzle data structure, and we're going to make sure this is an array so that we can request the puzzle for all of its information that we will need. Now we're going to need also a inventory interface so that it is a little bit easier to communicate between the actors. So inside of the inventory folder, I'm going to right click, add a new blueprint interface, and I'm going to call this inventory interface. Let's open this up. And so we're going to have two functions. We're going to have return inventory, which is going to give us a single output. And the output is going to be a, let's call this items. And this is going to be our data table row handle. And this is going to be an array so that we can ask for all of the items that we have. And then the second function is going to be the remove item. And all that this is going to have is a single input. We're going to pass along the index for the location that we need to clear out. So which item to remove. And that's going to be an integer and a single variable like this. So two functions. Now the next piece, I'm going to go ahead and create myself so I'm going to right click in the content folder. I'm going to go to the blueprint class and I'm going to create a actor component. So I have as little code as possible in the character so that this is easier to migrate to another character. So I'm going to add a actor component and I'm going to call this, let's call this, I didn't want to delete that. I want to do player puzzle comp. So basically player puzzle component. Let's pop this open and let's start working in this thing right here. So first, let's go ahead, let's add a new function and let's call this interact with a puzzle like this. So first, I'm going to do a box trace by channel so that I will use a box trace so it's a little bit of a bigger thing so it's easier to hit the puzzle. So what we're going to need is we're going to need to get the owner of this puzzle component, so that's going to be our player. From this we can get actor location and also we can get the forward vector of this same actor, so of our character basically. And then for the starting location, that's going to be our actor location, and then for the end position we're going to use forward vector multiplied. So we have a vector times vector, so we're going to right click the bottom pin and convert this to a integer. And let's say we're going to shoot this ray 1000 units in front of us. We're going to combine our location with this multiplied value, and that's going to be our end position like so. Now the next thing we need is the half size, so how big the box is going to be. So let's say it's going to be like 20, 20, 20, should do the trick. And then for the trace channel, in this case, I'm going to be using the camera trace because the visibility trace is going to mess with the, in this case, the built-in IK system that the character has. It's using a visibility trace channel. And then so that I can see the trace for now, I'm going to make this for duration so that we can debug this. And we can do an if. And let's just make sure that it actually does work. So let's go to our character. So third person character in my case. I'm going to do a keyboard E key event. I'm going to make sure to attach the components. I'm going to add a player puzzle component to my character. I'm going to grab this component and I'm going to run our interact with a puzzle function once we press the E key. So now once we press play, once we press E, we should have this thing ready to go. As you can see, it does detect the hit over here, but it does not detect the hit with the puzzle because there's nothing really that is blocking the camera trace over there, only over here as you can see when we hit the mesh, but the meshes are too small. So let's fix that. Let's go to our BP puzzle and let's select the self and let's add another box collision. Let's make sure this box collision is somewhat big so we are able to interact with the character, well, with the puzzle rather. So I'm gonna make this like 200 by 200 by 200. And this should do the trick. So now if we try this again, you should see that, of course it doesn't because I forgot the most important part, that our box collision, we need to change its rules. So we need to scroll down till the collision presets, and I'm going to change the preset from overlap all dynamic to a custom. and I'm going to make sure that I'm blocking the camera channel. So now you will be able to see that this does get detected. Okay, so that's good. So that means we can go back to our puzzle component and disable the debug and set it back to none. So let's start working on this thing. So what we're gonna need now is we're gonna need to break our hit result so that we can get the hit actor. So that's gonna be our puzzle once we try to interact with it. So we're gonna promote this to a local variable and call this L_hit actor. Like this, we're gonna promote this to a variable so we don't have too long routes. We're gonna need this in a bit. The next thing is we're gonna need to go ahead and return puzzle data. So we wanna request what items we need for this specific puzzle. So again, we're going to promote this to a local variable, call this local L_puzzle data. And then also we're going to go ahead and ask for return inventory. So we're going to ask the items from our player, and then we can get the owner of this puzzle component, which is going to be our player, and it's going to return us our player's inventory. So we can again promote to a local variable and call this L inventory, like this. Okay, so far so good. Now the next piece that we need to do is I'm gonna grab our puzzle data. I'm gonna go ahead and do a loop for each with a break, so that I would go through all of the components, all of the data that we have inside of our puzzle. We're gonna go ahead and break the arrays element. We're gonna break the puzzle data so that we would retrieve our item needed. Now I'm going to right click this item needed and I'm going to split this because all I actually need is the row name. And what I want to do is I want to check if this row name is equal to an item inside of our player's inventory. So for now I'm going to move this down so it looks a little bit better later in the wiring. And one more thing I want to do before I actually check whether we have this item inside of our inventory that is needed for our puzzle, I want to make sure that I actually do need this item so that I haven't already placed this, because if I already have placed the planet down, there's no point in me to place another one. So I'm going to do an if from this one to make sure I actually do need it. If I do need it, if it's going to be false, then in that case we can go through our inventory with another for each loop with a break. So we're going to go through our inventory. We're going to drag from the array element, we're going to break this, and we're going to check if the row names match up like this. And then it's going to be another if branch to make sure we have this item. And then if we do have this item, we can run our remove item message that we created through the interface. The target is again going to be the get owner, so our player is the owner of this specific component. And the index, well, it's going to be the index from our local inventory, so this guy right here. Now, last couple of steps that are left for us is to actually, so if everything works out, we have removed the item, so now we actually need to give item to the puzzle. We're going to give this item to the puzzle. The target is going to be our local hit actor, so the puzzle that we are interacting with. The item that we're going to give it is the item from our inventory loop. So we're going to grab this, plug it in, and the index in which we are going to place this in is from the first loop from our puzzle data. So we're going to grab this and plug it in here. Let's do a little bit of a reroute to make it not overlap as much. You'll probably do a way better job at rerouting than I have because I'm overlapping quite a bit over here. Okay, so far so good. Now, one more thing that we need to do is so that we don't run any unnecessary loops constantly, because we have found the item, everything has been done, everything's been successful. Let's go ahead and let's run a sequence node, which is going to allow us to first, then 0, break the inventory loop, and then we're going to also break the puzzle loop. Now let's do a little bit of a rerouting, and then we want to grab this give item puzzle execution and bring this to the sequence, so that once we are done, we initiate the sequence and we are breaking both of those loops because we no longer need them to be running. Now we need to make sure that we attach these interfaces that we created, so the puzzle interface and the inventory interface, to the correct actors. So first let's go to our third-person character real quick, and let's go to the class defaults, class settings rather, and let's add the inventory interface. Let's compile and save this. Let's go ahead, let's double click the remove item. It automatically will create the remove item function for us. And over here, all we want to do is we want to grab our inventory. We want to do remove index, connect the execution, plug in the index value, and then we want to refresh our inventory just like we did under the add item. So we can just go ahead, grab our UI HUD and do refresh items. So now this is going to refresh our inventory automatically once we remove it from the, well, once we remove the item from the inventory. And then we also want to run the return inventory. We want to actually return some info. So we're going to grab our inventories array and plug it in over here. So now once we execute this, we're actually going to return the inventory information as well. Now let's head into our puzzle master. So we have our BP puzzle master, and it doesn't have this interface. So we're going to go to the class settings and we're going to add our puzzle interface, and let's fill out the necessary info. So under the interfaces, we have the return puzzle data. So we want to grab the puzzle data and return this. And then we have the give item to puzzle function, which we're going to set up in a bit. So first thing, we need to somehow figure out how we can actually stop the puzzle from working. I'm going to delete this for now. How we can stop the puzzle from working if we haven't completed it. And for that, we're going to add a new variable, and we're going to call this ready to use, and this is going to be a Boolean. And then before we try to rotate this, we're going to do an if branch check, and we're going to check for if the puzzle is ready to use. And if it is ready to use, then we're going to go ahead and continue with our code. And this is going to allow us to block the puzzle. Now we have two options. Either we can set separately that some of the puzzles are ready to use. So let's say if we leave this like it is right now, and I don't need any items for my bridge puzzle, I would go to my BP bridge, and under the begin play, before I run the parent's code, I would set ready to use to be true like this. But I don't want to do that because most of my puzzles perhaps will not need these items. Most of them will be ready to use by default. So what I'm going to do instead is back inside of the puzzle master, I'm going to select ready to use. I'm going to make sure this ready to use is true by default, and then only the puzzles who actually need the items will have this set to false. In this example, it's going to be our BP round puzzle. So under the event graph, we're going to go ahead and set ready to use to be false. So by default, it's not going to be ready to use. And that means that if we would now hit play, you will see that if we enter the puzzles area, if we use the keys, nothing happens. While if we go to this puzzle right here, you can see it is still functional. Now, while we are still inside of the BP round puzzle, let's set up some more things that we need. We need to fill out the item needed. So what I'm going to do inside of the BP round, I'm going to add a new variable, and I'm going to call this just simply items. This is going to be our data table row handle, and this is going to be an array. And so we need 3 items. We have 3 inputs, 3 planets to place, 3 planets that we need to place down. So I'm going to add 3 entries, and I'm going to go ahead and select the item database. Index 0 is going to be the bottom ring. So ring number 1 is going to be, well, in this case, actually, it's the top ring. So it's going to be our Mars, planet Mars. So under the items, I'm going to select that this is the Mars. Then we're going to have our Earth. And then we're going to have the Jupiter like this. And then what we can do is we can get the items. We can get a copy to the 0 and item needed. And then we can do the same thing. Item needed. In this case, this is going to be the 1. So the Earth. And then the Jupiter is the number 2. Like this. Item placed by default should be at false. Like so. Now the next step is let's go back inside of our puzzle master. Inside of here, I'm going to add a new custom event, and I'm going to call this place item. Let's call this place item. And this guy right here is going to have 2 inputs. The first one is going to be the index. So again, the location for the planet index. And the other one is going to be the item, so that we can grab the static mesh from this. So we're going to use the data table row handle to grab the static mesh from it. Now I'm not going to do anything inside of the master. This function is going to get handled inside of the child, because only the BP round puzzle really will care about this. The other puzzles will not really care about it, so we don't need this code in all of those puzzles really. So let's head back. Actually, no, let's use this function over here, this actor. We need to give item to puzzle. Now what I noticed is that I made this give item to puzzle to be an event instead of a function. So what we actually want to do is go to your puzzle interface, select give item to puzzle, and make this into a constant. So open the advanced, make this into a constant, compile and save this, and now inside of your puzzle master, give item to puzzle is going to be a function, which is exactly what we need, because, well, we're going to hold a local variable inside of this, and it's going to be a lot easier with local variables rather than global ones. So what we want to do over here is, first we want to grab our data of the puzzle. We want to get a copy from the index like this. Now the next step would be to, we want to go ahead and drag from this get, and we want to set member in the puzzle data. And what we want to set in this case is we want to set that the item has been placed. We want to change this variable to be true. Then we're going to grab our puzzle data once more, and we're going to go ahead and set the array element. The index is going to be, well, this index right here is going to be the one that we're going to be using. Let's do a little bit of a reroute again. And then the item is the structure out like this. So this is going to replace the data information about that this specific puzzle piece has been placed down. And the next thing we want to do is we want to use our place item function that we created. Previously we left it empty in the puzzle master, but the child is going to take care of this code. So index, the same index, and the item is the item from the input like this. The next thing that we need, we have a error, so that the place item can be modified state and cannot be called on itself because it is a read-only target in this context. Let's see, let's go back to our puzzle interface. Let's change the constant back to false. And this is still executed as a function, but now this thing works. Okay, so that's good. All we care about, so that this is a function, so that we can hold the local variable really. And then the next thing is we're going to go again, grab our data once more. And because now we need to check if we have placed all the items down, because if we have, we can be ready to use the puzzle. So let's loop for each with a break through our puzzle data. And over here, we're going to want to drag from this, break the puzzle data. And we want to check if this piece has been placed. So we're going to go through all of the pieces, and we're going to check if all of the pieces have been placed down. I'm going to hide the unnecessary pins. And like I said, we need a local variable. So I'm going to check if L_all done. And by default, I'm going to make sure that this all done variable is actually set to true. And once this branch fails and it goes to false, we're going to make sure to set our local variable to false. And then at that point, we're going to go ahead and hit the break on our loop. And then once the loop has been completed, we're going to go ahead and set our ready to use variable to match exactly with the all done local variable. So if one of the items is missing, it's going to say that no, the puzzle is not ready to use. But if we have all the pieces, it's going to be ready to use. Good. Okay, that's good. Now the last piece is to actually set up this place item function, which is empty inside of our puzzle master, but inside of our BP round, we do want to run some code on it. So we're going to run our event place item. Over here, we're going to want to do a switch. Not this. We want to do a integer switch. So we're going to have 3 entries because we have 3 planets. So we have 1, 2, 3. And what we want to do is actually, we're going to right click this. We're going to collapse to a function, and let's call this place planet. And we also will add another input. So let's rename this to index first. And we have another input, which is going to be the item. So we pass along the item as well, which is the data table row handle. So it looks like this. Now inside of this place planet, we have our switch. We're going to add a local variable. We're going to call this L component, so local component, which is going to be a single variable, and this is going to be a scene component. Now I'm using scene component so that I can use any component inside of here. So I'm going to set this to be my arrows. So we have 0 is our Mars, like this, and then we're going to have 2 and 3 as well. 1, 2. Now, just to make sure that I'm setting up the correct placeholders, I'm going to go to the viewport and I'm going to double check this. Well, actually in the event graph up here. So we have the index 0 for ring 1, which is our Mars. So index 0 is going to be the Mars. So index 0 Mars. Then we're going to have index 1 is going to be our Earth arrow, Earth place, and the Jupiter place is going to be the last one, like this. So that's good. So we have the location component set up. The next thing we want to do is we want to add a static mesh component. At least I'm going to be adding a static mesh component, and that's going to come out of all 3 of these. We're going to split the relative transform so that there are some values inside of it. And then we want to, from the return value, we want to set static mesh, like this. Before we can actually set the mesh, we actually need the mesh. We can grab that from our item. So we can break the data table row handle, like this. And from this thing, we will be able to get a data table row. So we're going to connect the execution, connect the row name. Then we can go ahead and break our inventory structure, which will actually return us the mesh, like this. So now we have set up the mesh as well. Now the last thing left for us to do is actually grab this component that we just created, our mesh, and we want to attach this component to another component. We want to attach this component to whatever one of these we used. So our planet placeholders. So we're going to grab our local component, plug it into the parent, and change all of these rules to snap to target so that they would match up with the parent. And at this point, we should be ready to go. So let's go ahead, let's hit play on this thing. Let's go ahead, let's collect our items. So we have our 3 items, and then if we walk up to it, press E, there we go, planet 1, planet 2, planet 3. I made a bad design over here, so the planets are a little bit too big. But if we try to interact with the puzzle now, we should be able to do so. There we go. Now, if we would try to interact with the puzzle before it has been fully assembled, you will see that nothing really happens, and we're going to be still able to interact with this one, as you can see. But this guy doesn't seem to work up until we place all the pieces down.